Hi, this is Joe Nolan from Gibson Engineering. Today we're going to walk you through setting up an L-Series PLC with CC-Link card to communicate with a intelligent actuator Pecan CC-Link controller. In our case we have just a single Pecan, however this could be a multi-axis system on the CC-Link network. The intelligent actuator settings are just a few parameters, physical address switch on it. You can reference our QuickStart guide to see how those should be set to follow along with our particular guide. But for this video, we're going to focus on the PLC side and that setup. So I've got GXWorks 2 open, no project yet. I'm going to start a new project. It's a structured project for the L series. Hit OK. Now I've got my project. First thing I'm going to do, doesn't need to be first, but I'm going to go in and set our CC-Link parameters. So I go to Parameter, Network Parameters, CC-Link. I want to say I've got one module. Starting I/O number is 1. We've got a version 2 card. Transmission speed. So this should match a parameter that you set in the intelligent actuator controller. We set ours to 5 megabaud per second. Total modules connected. Again, in our case, we only have one. If you had multiples, that's where you would want to put that in. For the total modules connected, if you did have 2, you want it to be 2. If you had 3, you want it to be 3. It's later on where you need to make sure that you skip a station, because the mode we're in for these IAI controllers, they're going to consume 2 stations. So input bits, we're going to start with B0. Outputs, we'll choose 100. So the words, the registers we're going to write to, we're going to start with W0. Go to W100 for the right registers. Station information is the next thing you need to set. We do not, so where we chose one module over here, it only shows one. If we had chosen multiples, you'd see multiple here. So it shows module 1 and then station 1. If we had 2, it would show module 2, station 2. However, we're going to go and choose remote device station. We're going to say it occupies 2 stations, which is 64 points. So now, once you do that, if you did have 2 or more axes, you'd see it skip a station number. So for module 1, it'd be station 1. Module 2 would be station 3. Module 3 would be station 5, etc. Now this is all we need to set here. But make sure you click End. And again, on these CC-Link parameters, you want to hit End. So that's the communication setup. Next, what we're going to do is import a library. So Gibson Engineering has developed a library which includes a function block and the corresponding labels specifically for the L series to talk to a CON type controller. So we're going to go to our user library. See, we've got nothing in there yet. We're going to install it. I'm going to browse for it on our local PC. It goes right to the folder I have it in. And choose that CC-Link Pecan library. Hit OK. Let's install the library, and now you see the library in our user library tab. Everything's grayed out now, so what we do is we right click, we hit open, now you can see everything. Labels, any functions or function blocks you have, and any structured data types that were set up as well. Now we do need to bring over our label data. So we're going to take Axis and Logic, highlight them, copy, and we're going to go back to our project, go to our global labels, paste it right in. Now, our project can't share the same data names as our library. So we're going to change this to Axis 1. Logic, we can just change to logic bit, because that, you'll see later, can be used for multiple axes. Hit OK. So now we've got access 1 and logic bit under our global label data. This global 1, which was in there by default, we can get rid of it if we want and delete that. Now if I go to access 1, you're going to see all our label names. The first two are structured data types, control and status. If we click on the detail setting, you're going to see that those are set up to start at the same addresses we chose for our CC-Link configuration. If you had multiple axes, you'd have to offset them 128 points, or 8 words. For axis 1, it's W100. If you had axis 2 and you duplicated this, you need it to be W108. Status starts at W0. And then again, if you had another axis, you'd want to start that at W8. So that's fine. However, the label names are not fine. Those are still going to be the same as the library we cut and pasted from. So we need to change those. Easiest thing to do, find string. We're going to find axis and replace it with axis_1. Now I don't necessarily want to find it in the entire project. I want to find it in this current window. For now that wouldn't matter, but if I was doing multiple axes and I had a separate data set for each of those, I wouldn't want it to go and change all of them. So I'm going to do current window, and I'm going to do an all replace. Say OK. Now you can see it's gone through and changed all of those. We still have our logic bit. Go over there, we can see it is in fact just one bit, and the label name needs to be changed. You can do a find replace. There's no benefit here. There's only one of them. I'm going to change it to PLC_always-on, and you can see that that device is SM400, which is an always-on bit. So that's all set now. Our labels are all squared away. Now we've got a POU, the default POU_01. I'm going to go ahead, change that name to axis_1. You can see our program still blank. Now while we're looking at this, I'm going to show you that under this program setting folder, you can see different types of programs. By default, it sticks your first program under no execution type. Because it's under main, it will actually run, but if you create additional programs, you don't want them under no execution type, or they're not going to execute when your PLC is in run. So you want it to be a scan program, initial program if you needed that, fixed scan program if that's critical. So I'm just going to move this to scan program, and it's a good habit. So now we've got axis 1 under our scan program. So now we've got this blank program. I'm going to go back to my library. I'm going to take this function block that exists in there. I'm going to drag it right over. Now this is where you can assign the labels, this dialog box. It comes up with the same name as the library had. I'm going to change this instance to axis 1. I'm going to minimize after I apply, so then that dialog box will get minimized and you can see what's there. All of our status is on the right, all of our inputs are on the left, and we got to go in and assign labels to all these. So the first one, EN, is just an enable. Unless that's enabled, function block's not going to run. So we're going to double click on that. This is where we're going to use that always on label that we set up. So it's under logic bits. It's not a function block, it's a simple data type, PLC always on, hit apply, and now that's there. So now the next one is axis status in. So now this is not in the logic bits, this is in axis 1, and it is a structured data type. So I'm going to choose axis 1 status, hit apply. Now we just got to go down the list. We're back to simple data types, and this is just servo on. Call it axis 1 on. Jog forward. reverse. Start move. Reset input. Assign the home. Servo position, and you can see this looks a little different. It knows based on the function block that we need a double word here. So we've got our position label. Servo speed. Excel decel. Again, it knows the data type, so it's only going to show the ones that are relevant. Position band. Now in this library I happen to know we're going to choose position band, but I happen to know that it's set as a constant. And the servo push was not actually defined. Go back and look at our labels. There's no push in there, and you can see again position band was set as a constant. So again, if I go back to our program, servo push we don't have, we don't need to use it. So I'm going to just cut that question mark right out. So now on the output side, we're not going to create any additional programs other than just using this function block or any additional programming. So we don't necessarily need the labels to be assigned to all these, but we can have question marks. So the control one we do need just to assign that structured data type. Double click on that. Command, apply. Now the rest of these I can just go ahead and get rid of. You could assign labels. There are labels defined in that library. And that's all we need. So now, outside of the program, we need to set up our connections. So if we go to connection destination, we've got all our connections that we've defined here, and then the current connection. If we go into connection 1, you can see there's the PC side, other station settings, PLC side, and you can also do PLC direct coupled setting. It'll automatically set everything. So I'm going to do that with USB. Hit yes, do a connection test. It says I'm connected. Hit OK, OK. You can see I can go and rename this USB connection. If I want to add a new connection, say I want this to be my Ethernet. Hit OK. Double click on that to set it up. And I can do the same thing. I don't have a hub, so I'm going to do PLC direct coupled connection Ethernet. Hit yes. Now if I go look at my settings, nothing there. PLC module, you can see Ethernet port direct connection. So if you had a hub, you could check this box, you could assign the IP address, or you could find the CPU's IP address and then use it. Do a connection test now. Successfully connected. So you can see we can jump back and forth between connections. Current connection is USB. I can drag Ethernet up there, connected with that. Or I can go back to USB. So now that those are set up, we can download a program. So first what we want to do, rebuild all. Yes. No errors. Online. Right to the PLC. And one thing to point out here, in our case the symbolic information is not going to be particularly big, but the symbolic information can get to be a memory hog, so it's good practice. Turn that to standard ROM. PLC data can go into the program memory. Now I'm just going to download parameters and programs. Execute. Yes. I can overwrite the parameters. Check this button so it closes when it's done. can do a remote run, and it's all complete. Close this window. So now I can go in online, start monitoring. You can see I'm now monitoring. So the always on bit is on. Nothing else is set yet. Another way to see that is I can create a watch window. Nice feature is I can right click right on this function block, register to watch. It now creates a watch list for this function block, which includes everything connected to it. See, there's just dots not being watched yet. If I go online, watch, start watching, go back and look, see they've all been populated. So now if I go ahead and look at the function block, double click on servo on, say turn it on, it's turned on now. You can see the bit there. Our servo on, we could start turning bits to jog, home, start a move if we had put in a position. But we've also created a soft GOT program that we can use as user input. So now we've got our soft GOT. You can see our servo is already on because we had turned that on through the PLC software. Now we can home it. We can jog. We can also go in and set positions. 100 millimeters. Set a speed, 200 millimeters per second. Should we set an XL and decel value to 0.3G. Now we can do a start move. Move to our 100 point. Go back in, change that to 0, and go right back. Now we can also do that with GXWorks too. So if we go in and set a position, so you can see we've exposed all the basic functionality of the RoboCylinder over CC-Link, like jog forward, jog reverse, home, position moves. So now you can use those labels we created within your program to create whatever kind of functionality you need. If you have more questions, please reference our QuickStart guide or contact Gibson Engineering.